When an interface from your router has OSPF turned on and plugged into a network, it will start trying to communicate with other devices. But what happens is when it establishes connections, it goes through a process and several different states as it's establishing communication. So let's take a look at what states they go through and how it sets up the connections with these devices. Hey Techno Studs! In this video, we're going to be talking about OSPF states. We're going to talk first of all about the different OSPF neighbor states that exist, and then we'll take a look at what it looks like once your neighbors are converged, once all communication has been established and you have full connectivity to those neighbors. Then we're going to get into what's going to happen when there's changes on your network, when there's topology changes and OSPF needs to make corrections. So what is the OSPF neighbor states? In this example, we're going to say that there's R1 is talking to R2. So we'll do R2 right there. And first of all, R1 is going to start in the down state. And down state just means it's sending out hello packets, but it hasn't received any hello packets yet. So everything is going to start in that down state. Then it's going to jump to this init state. So notice I skipped the attempt. That's because that's specific to certain networks and we're not going to really deal with it. And some literature doesn't even have that listed as an option. All right, so next, this init state, what happens in this init state is that R1 receives a hello packet from R2. But within the hello packet, we know that R2 lists out all of its neighbor relationships, all of its neighbors to R2. So this init state exists when that hello packet does not list the RID, the router ID of router 1. That tells that router 1 that router 2 has not received a hello packet yet. As soon as the hello packet gets to R2, and then R2 sends a hello packet to R1, and the router ID of R1 is in that hello packet, then it knows, oh yes, we now are on the same wavelength. You see me and I see you. So then it goes into a two-way where they now see each other. And so once they've seen each other, that's when we say the neighborship is established. So we've got a true neighborship going on there. And part of this will also elect a DR and BDR, so that's where that takes place as well. All right, so this is the division line right here. You know, some of these relationships never progress on past this, and we'll see what that looks like here in a little bit. But the next state right here is going to be the X start state. The X start state is going to be when the DR and BDR establishes a primary and secondary relationship. So the X start is actually, the next couple exchanges here is just establishing the database and getting the database going. And so the DR and BDR actually have to communicate back and forth and figure out who's going to be the primary or secondary, or you can also see it in some places listed as master and slave. And whoever becomes the primary is going to have the higher our router ID. So the higher router ID becomes the primary, and the lower router ID becomes the secondary. So in that it could be different than the DR and BDR. If there's a priority set on those, the DR and BDR use this as a different set of criteria, which is kind of interesting that the primary may not be the DR. But this just is a designator just for these initial stages. So based on the router ID, that's going to select a primary, and then the primary initiates an initial database sequence number. So a database sequence number gets started, and that's going to be the basis for this first initial configuration. Once that's done, then it goes into this exchange mode. And in the exchange mode, that's when these database the database packets get sent back and forth, and it builds this linked state database. So it's getting all of these updates to the database. The database is incrementing through this sequence number, and only the primary can increment the sequence number. So the primary will increment the sequence number, and the secondary will acknowledge the sequencing of this database. Once it's done that, then it goes into the loading state. So the database just has the link state advertisements headers in it. So it's kind of like a synopsis of all of the different links that are out there. And so it builds this whole database, has a synopsis of what the database should look like, and realize, okay, now I actually need the information about these link states. And so now I'm going to send out link state updates or link state requests and get link state updates back. So the designated router is going to send out all these, hey, I need these updates, the link state requests. The link state updates are going to get sent back. The link state updates has the full link state advertisements, not just the header, but the full link state advertisements. It gets sent back to the designated router, and now the designated router then communicates and sends out link state updates to the rest of the devices. Once that's done and everything is fully converged, then we say full. Everything is in this full state right here. So once everything is fully converged and everything is communicated, then we are calling that the converged neighbor state. This is when the DR is elected, the BDR is elected, and everybody has their link state database is all up to date. And so what's going to happen is we're going to have several types of relationships that are going to exist in this case right here. So first of all, we've got a full, this means that everything is up to date, the link state databases are synced, and this is the relationship with the DR. So this would be from any of these devices to the DR, to include the backup designated router to the DR. This is going to be listed when we do the show IP OSPF neighbors. And then, so that is the neighbor with the DR. Then we see this full BDR, and this is any device with the backup designated router. And then we have the full druther. This is when the BDR or DR is connected to any of these devices. And then finally, we have the two-way druther. So this would be just between two devices here. Now, what's going to happen is between the BDR and DR and any of these devices, they're going to have all the communication. But between any of the druthers, we don't have link state updates, we don't have link state acknowledgements, we don't have link state requests. Those are only going to be sent to the designated router and the backup designated router. So, but do notice that we still maintain relationships with all of the devices on this network. All right, let's watch what happens when there is a topology change. So first of all, just know that we have hello timers, we have the database timer, we have a link state request, a link state update, and a link state acknowledgement. So those are the different packets that we have that get sent out. Well, the database ones are only for the initial setup. So we mentioned how the database gets, the DR is elected and the database gets all passed around to the DR. The DR creates the link state database here and then sends all the updates to the other devices. Once that's done, then that comes out of the picture. The next thing to know is that all the other devices are going to every 30 minutes send out a link state update to the DR, and it sends it out to 224.0.0.6. It's a multicast address, and so the DR is listening to that multicast address, and that happens every 30 minutes. And it's going to contain all the link state advertisements. So remember, the link state advertisements are information about each one of the links, and that just refreshes it to make sure that the database is always refreshed. But the other thing that's going to happen is if there's a change to the topology, let's say there's a link on this router that goes down, that's also going to trigger a link state update. And it's going to send a link state update with that link state advertisement with the change to it. That's going to go to this DR. Once again, it's a multicast, so it's being sent to this multicast address. And then this designated router is going to update its link state database and then send out that link state update to all of the other devices. And then a link state acknowledgement is sent back. So link state acknowledgement. And everything that goes to the DR is going across this 224.0.0.6. So that way it's just the designated router that's getting that update. And actually the backup designated router is getting those updates as well, just in case it needs to take over. But then when communication is happening from the designated router to all the other devices, that's happening on 224.0.0.5, so that all the other devices can listen to that. And your hello packets get sent out on that also, because they're all maintaining relationships with each other. They all create those adjacencies. So that's the topology changes. If there's a topology change, everything goes through that designated router. So there we have it. We talked about those different OSPF neighbor states, and as it's establishing communication with each one of its neighbors, it's going to bring that communication through those different states. And then what we'll see is if we do the IP OSPF neighbor, we'll see what states those are, and once it's fully converged, we'll either see that it's fully converged with that other device, or that it's in a two-way, which means that two-way is just between two druthers and not necessarily between a druther and a designated router or a backup designated router. And then we talked about what a topology change would look like and how everything gets communicated through the designated router, and the designated router then communicates that change out to the rest of the devices.